The health of employees is monitored by periodically weighing them in. A sample of 54 employees has a mean weight of 183.9 lab. Assuming that variance is known to be 14,689.44 lab, use a zero point 0.1 significance levels to test the claim that the population mean of all such employees weights is less than 200 lab. First, let me write down all the information we have. Here, a sample of 54 employees has a mean weight of 183.9. That means we have a sample, that sample size, which is n equal 54. And they talk about their mean, the sample mean. So sample mean is x bar. X bar equal 183.9 lab. We have variance is known. Okay, variance is what? Variance is the sigma to power 2. So we know that, but we need sigma. So sigma equal square root of this number 14,689.44. That square root is 121.2. So that is the sigma. Then use 0.1 significance. So what is the significance mean? It is alpha. Alpha equal 0.1. Now test the claim that the population mean of all such employees' weight is less than 200. Okay, what is the claim? Claim is less than 200. Therefore, H naught, we know always we use mu equal mu naught. Therefore, this one mu equal 200. Versus HA, we need to check the claim is less than 200, therefore mu less than 200. So this is the null and alternative hypothesis. Then we need to decide step 2 alpha. Yes, alpha is given, so alpha equal 0.1. Then go to the step 3 in our note. So step 3 is find the test statistic. What is the test statistic we use? Yes, now go back to the information we have. Okay, we have sigma here. Sigma is the population mean. When we have population mean, we know we use Z naught. So Z naught equal x bar minus mu naught sigma over root 10, because sigma is known. So we can plug the numbers 183.9 minus 200 divided by 121.2 again divided by root n equal 54 square root. So this answer is negative 0.98. So this is the Z naught. That is the test statistic. Once we have test statistic, what is the next one we need? We find the p-value. How do we find the p-value? Yes. Now go back to the HA, alternative hypothesis. What we have? It is one tail test and also left tail test, less than, right? Therefore, draw the normal curve, left tail test. So we have this side. So this should be Z naught negative 0.98. So we need to find this area. So that is the p-value. How do we write this? P-value equal probability Z less than or equal Z naught, right? Z0 is negative 0.98. So now you know how to check the table. Please go back to the Z table, check this number, it should be 1635. So this is the p-value. Now decision. Decision is, you know that if p-value less than or equal alpha, then we say reject x0. That is the decision. So let me check. Our p-value is equal 0.1635 and alpha significance level is 0.1. So which one is the greater? This one is the greater. Okay, if p-value less than or equal alpha, reject. But here p-value is greater than alpha. It means opposite of this condition, right? Therefore, what is our decision? We can say fail to, therefore fail to reject H0 for alpha equal 0.1. So you see that fail to reject H0 for alpha equal 0.1. That is the decision. Now conclusion. How do we write the conclusion? Our decision is fail to reject H0. Okay, this is the H0 we use and this is the HA. Fail to reject H0 means we accept this one, in other words, right? But we don't write that way. We write just fail to reject H0 for alpha equal 0.1. I will explain why I write this sentence. But here fail to reject means we accept H0. It means mu equal 200, right? Mu equal 200. Therefore, our conclusion is there is not sufficient evidence to warrant the rejection of the claim that the mean equals H0. H0 mean equal 200. Alright, let me explain something else here. So suppose we have alpha equal 0.2. So if significance level alpha is 0.2, what will happen to our decision? Then actually you see p-value 0.1635 and alpha is 0.2. So then you see this greater than. Therefore, if p-value less than or equal alpha, here p-value less than alpha, yes, that's satisfied, right? Therefore, reject H0. Therefore, we can say H0 is rejected. If alpha equal 0.2, our decision is H0 is rejected. Therefore, you should understand here, when we change the alpha value, this decision may be changed, right? Yes, our decision based on the alpha.